We are on question number 10. Now, we've moved out of one-dimensional motion graphs, and now we're talking about relative motion. It depends on your frame of reference how fast it appears things are going. All right? Now, I'm going to show you that right here in this problem. You're going to have 2 or 3 of these problems on the exam, guaranteed. Let's read it. It says, Bobby sees Guadalupe running towards him at 8 meters a second. Now, I want you to just stop right there. You might be like, oh, do I have to use a equation? Do I have to talk about acceleration, velocity, whatever, velocity, distance over time, acceleration, final minus initial over time, or whatever? Do I have to do that? Let's see. While running, Guadalupe yeets a ball towards Bobby at 6 meters a second. How fast does this ball look like it's going to Bobby? Now, whenever you see that, how fast does it look like it's going to Bobby, right? You know that we're going to be comparing how it looks from one observer to another. And for that, we have to draw a diagram. We're going to draw a diagram right now. So I'm just going to draw out the situation. Bobby sees Guadalupe running towards him. So I'm going to draw Bobby real quick. And I'm going to diagram this entire scenario. I want you to as well. Here's Bobby. And he sees Guadalupe running at him. Running at him, full speed, boom. Running at him, right? So her direction of travel is at Bobby. What is her velocity running at Bobby?
8 meters per second.
8 meters per second. But that's not all. What else does she do?
She throws a ball.
She throws a ball. She yeets a ball at his face. How fast is the ball going?
6 meters per second.
6 meters per second. So I want you to put yourself in the position of Bobby. How fast does this ball look like it's going to Bobby?
You got that 8 meters per second, which is like the acceleration, right? For the ball.
Well, I mean, let's think about it. If Guadalupe was standing still and she threw the ball at 6 meters a second, the ball would look like it's going 6 meters a second. But that's not what's going on. She's running towards him. So how do you think the ball looks like it's going faster or slower to Bobby? Faster. Because Guadalupe is already going 8 meters a second. She's already running, and then she throws it, right? This is relative. Now, if I was running alongside Guadalupe and she threw it, it would look like it's going 6 meters a second as well. But it depends on the observer, the frame of reference. To Bobby, this thing looks like it's going real fast, right? Faster than it would be if she was standing still, that's for certain. So, here's a quick tip. If the velocities are in the same direction, to an outside observer, you can add them together, right? You can add them together. It's hard to create a rule, though, when you don't diagram it. And I'll show you in the next 2 why that's important to draw the diagram, because you'll get the directions mixed up, yeah? So this, question number 10, relative motion, Guadalupe yeeting a ball at Bobby while she's already running. Boom, you added them together. That ball looks like it's actually going 14 meters a second. 8 with her original motion and the 6 that she threw it with. That is relative motion. Question number 10.